Yeah.
Go ahead.
Wait, I forgot to square the point too.
Yes. Yep.
Just because it's not your day today.
Be careful. Now, is anybody thinking this concept is overwhelming and difficult?
No.
It's very easy. But it's easy to make mistakes too, isn't it? So be careful and you'll be fine.
It's
You all right?
2 points. It's 2 points.
there you go.
2
No one else Jessica did today.
Spencer,
Jessica,
let's move along.
where is everyone?
This is the last topic that we're going to hit today. I'd like to go over this slide. We'll do an example on the next slide, and then we're going to be done. It makes a difference what the environment of the solution is that you're dissolving things in. The pH of a solution when you're dissolving a solute can affect the solubility. Let's take a look at this. I'll have you write this down in a moment. Silver phosphate. This is not very soluble. When silver phosphate dissolves, you get some silver ions and phosphate ions, and it only goes to the right a tiny little bit and then stops. It's not very soluble. However, if you put silver phosphate into an acid solution, how would the acid environment change the solubility of this? What term in this reaction would be affected by the presence of an acid?
H plus ion
PO.
would combine with
PO.
or negative.
This thing right here. Why? Why would hydrogen ions like the phosphate ion?
Phosphoric acid.
Well, this is a base. Yeah. Because phosphoric acid is a weak acid, and so its conjugate is a base. So the presence of hydrogen ions is going to cause these phosphate ions to absorb and to take on those hydrogens. And what does that do to the equilibrium reaction, according to Le Chatelier? We're removing one of the products as it gets reacted with the hydrogen ion, which causes this reaction to continue going right, which is doing what to this solid? Causing more and more to dissolve. So if you dissolve this in acid, just about all of the silver phosphate will dissolve. Whereas if you just put it in pure water, it's just going to sit there and hardly do anything. It won't do anything noticeable at all. So that's what I'm saying here. And this part in red is, I think, the most important thing for this part. I would highlight that myself. Salts with basic anions, they'll dissolve better in acid environment than in pure water. You have to look at what the positive and negative ion are. If the negative ion is basic, which means it's the conjugate of a weak acid, then it's going to dissolve better in acid than it does in water. So this is not a new concept either. This is just Le Chatelier's principle and acid-base chemistry, where you need to look at that. If that is basic, which it is, then if you put this into an acid, the hydrogen ions in the base are going to react, removing that base and causing it to shift to the right.
Did you already tell them what the review was going to be for the next
No,
one?
I didn't.
Okay.
I will tomorrow.
Oh, maybe there's more. What's that in the background?
Oh
We already
yeah.
went over this.
Just crystals dissolving.
Or ice cubes falling. Is this it for you guys?
No.
Almost. We'll do an example.
Thanks.
Yes, we do have a reading quiz tomorrow. Has anybody read?
No.
Wait, look at what the reading assignment is.
1 page.
1 page.
752.
I can't wait for that one.
Wait, so the posse is still like, if you get a cheddar fruit, it's like 100.
Wait,
You just have to pass each one. You don't get any free ones.
wait, Mr. Ward.
Wait, what?
Wait, what?
You passed 2 of the fruit, right?
No, no, no.
That's
2 out of 3 questions correct.
Oh.
So your grade on the reading quizzes for the unit is out of 3. If you pass all 3, you get a 3 out of 3. If you only pass 2 out of 3, you get a 2 out of 3 for your grade.
D plus. Uh-oh.
There will be 3 grades for reading quizzes in a quarter because we're covering 3 different units.
So there's gonna be 9 total. So basically we can only get one of them.
Yeah.
That's fair.
All right,
What the heck?
Spencer, let's move on to one more. Now take a look. I know that your attention is starting to wander. We have, this is number 44 in the book. So number 44 would say just this: which salt in each set, so we're just looking at the first set in A, one of these will dissolve better in acid than the others will.
Second one.
Second one.
The first one.
Wait.
All of them.
Now, time out. When silver chloride dissolves, it doesn't dissolve very much. You know, chloride, it's soluble in everything except for one of those is silver. So silver chloride, you get a tiny little bit of silver ion, a tiny little bit of chloride ion, then it's done. It comes to equilibrium. But those chloride ions in acid, did they do anything?
Yeah.
No, because
Wait.
they don't get back together.
We are never
Oh.
getting back together. This does nothing in an acid. It doesn't care if you're in an acid or if you're neutral water. It's not going to do anything with the hydrogen ion. So this is not affected by acid. What about this?
It's a strong acid.
Conjugate of strong acid. Nope. Does nothing. What about this one?
It's a weak acid.
HF is a weak acid. So the fluoride ion is basic. It loves those hydrogen ions. So this is going to grab onto the hydrogen ions, causing the silver fluoride to shift away and make more silver ions, more fluoride ions. This will dissolve better in acid than it will in pure water. So this would be the answer for A. For part B, lead hydroxide, lead chloride. Which of these will dissolve better in acid?
Hydroxide.
Yeah. The hydroxide ions, when that little tiny bit of lead and hydroxide break apart from each other, well, those hydroxides, if there's acid around, they grab onto one another, which causes the reaction to start shifting to the right. And this will dissolve a lot better in acid than it will in pure water. You with me on that? What about this one? Yeah, the NO2 is basic. The NO3 is a conjugate of a strong acid. This doesn't care about hydrogen ions around, but this does.